So we're going to look at the focus and the directrix of a parabola. You probably have something, or some of you probably have sitting in your backyard, something that looks like this. And it's what you get your TV from. The TV waves come in to your house, come in and are you aim this parabola at those waves, and as they come in, they bounce off the parabola, and they all end up going to the focus. And that focus, you'll see you have a microphone or some sort of pickup at that point, so that all of the TV signal waves are focused to this one point where it's easy to pick it up at. So the focus of the parabola is at this point P, 0P. This parabola is one of the standard, and the parent function has a vertex at 0, 0. The directrix is the other new word for you. The directrix is this horizontal line that is equidistant from the vertex to the focus. So this distance is P here, this distance is negative P, or the distance is P, it's in the negative direction. So in this case, the equation of this horizontal line is y equals negative P. The focal distance, P, is the distance from the origin to the focus, and from the origin to the directrix. We take the value, absolute value, because distance is always positive. Any point on this parabola is equidistant from the focus and from the directrix. The distance from the point xy to the focus is the same as the distance xy to the directrix, and of course that would be a perpendicular. You drop a perpendicular from that point. So each point is part of the parabola. It is equidistant from the focus to the directrix. If you will, now is a good time to stop this video and watch the other little clip that I've sent for you. It shows you one way that they can be created. The parabola can be created. So using the general formula for the points 0P and xy, if we use the distance formula, right, we're going to set this distance equal to this distance. This, of course, is y plus d, y plus p, excuse me, y plus p. It's the distance from this point plus this distance, all right, equals the distance from this point to this point. Right, so the p value plus the y value. So square both sides and simplify, you get x squared equals 4py. And more familiar with y on the left-hand side, y equals x squared over 4p. So if you will, the value of a, the number in front, the ax squared plus bx plus c, the coefficient of the x squared term is always 1 over 4 times the distance, the focal distance. The distance from the vertex to the focus is always 1 over 4p. So if you have the equation y equals 1/2 x squared, that's y equals x squared over 4p, and it's also equal to x squared over 2, so you set them equal. And if you will, you can also do, as I was showing you before, 1/2 equals 1 over 4p, and this gives you p equals 0.5. And so we come up here, go to 0.5, put our focus, and our directrix will be y equals negative 0.5. And there's the directrix right there. We can also have parabolas that open to the right and open to the left. And it's very similar in this case. The directrix is x equals negative p instead of y equals negative p, because now we have a vertical line instead of a horizontal line, which we had before. This distance now is p comma 0. That's the distance from the vertex to the focal point. And of course, we still have an xy out here, so the equation is now changed to y squared equals 4px, and now a is equal to 4p. So if the focus is at negative 2, 0, and the directrix is at x equals 2, here's my directrix drawn out here, here's my focal point, negative 2, 0, and so it'll open to the right. So after the sketching, so the equation y squared equals 4px, in this case the distance between the is from 0 to negative 2, p is negative 2, so 4 times negative 2 is negative 8x. And we can also move the vertex off of the origin. To do this, just as we've done before, x minus h squared equals 4p times y minus k. That's for a vertical vertex. Parabola is vertical. Here the parabola is horizontal, and it changes to y minus k squared equals 4p times x minus h. And of course, in this case, hk is the center, the vertex, and here also hk is the vertex, but of course the k goes with the y and the h goes with the x in both cases. So we now have and want to graph x squared equals 14y, and of course y is equal to 1/14 x squared. So 1 over 4p equals 1 over 14th, so 4p equals 14, and p equals 3.5. So here we have our focus at 0, 3.5, and our directrix at y equal negative 3.5. If we had a vertex at 0, 0, and it is along the horizontal axis and passes through the point 2, negative 1, what's the equation? Well, y squared would equal 4px. We could plug that value, negative 1, in for y and 2 in for x, and we can solve and find that p is equal to 1/8. And since 4p equals 1/8, then p equals 1/2. So we'll have y squared equals x over 2. And lastly, the equation x plus 1 squared equals negative 12, y minus 2 is going to be an up and down because it's negative, and it's the x squared. In this case, since negative 1/12 equals 1 over 4p, then p equals negative 3. So we know the vertex is at negative 1, 2, so there's the vertex, and we go up 3, or down 3 in this case, to find our focus, and I would go up 3 to find our directrix.